Hello, guys. So we'll continue from where we stopped. Collision theory. Collision theory states that in order for reactants to react with each other, particles must collide in the correct orientation and with sufficient energy. So there are two things that we need to take note of there. The first one is correct orientation. So one, we need correct orientation. And two, the particles must have sufficient energy. So this theory seems to suggest that if you have reactants in a system, they are constantly moving. Let's say if it is in a solution, the particles will constantly be moving. So the particles it is talking about here ions, could be ions, molecules, or compounds. So these are the particles it is talking about. They are in constant motion. And for a reaction to occur, they need to collide. And the collision needs to happen in a correct orientation, and they must have sufficient energy. So let's look at the right side of the screen. Now over here, let's say these are particles of reactants, and for products to be formed from this reaction, we need to have the blue ends colliding with the blue end of another molecule. And for us to have a product, this collision must be heads-on collision. And if we are able to form a product, then we'll say that that collision is an effective collision. Then we'll say that that collision is an effective collision. So the things we need to look at is that we have the correct orientation and then we have sufficient energy. That will give us effective collision. Effective collision. Now we can also have a collision, but then the orientation might not be correct. So if this is going this way and this is coming this way, we might not have an effective collision. And therefore, the particles will just bounce off each other. That means that one, they don't have enough energy. Is that okay? In this particular case, let's call this A, let's call this B. In B, we'll say that the orientation is not correct. So we are not going to have an effective collision. So we have what is known as non-effective or ineffective collision. So ineffective collision. Now let's also look at C. So if this is C, we notice that the particles may be able to collide, but then we are not having the right orientation once again. We need blue and blue to collide for us to have a product being formed. But because they are not in the right orientation, we are not going to have the products from this reaction. So we'll say that again, it is a non-effective collision. So again, we have non-effective collision. Now, in the last example, let's say that these two are oriented correctly. So this is D. I will say that the particles have the correct orientation. But then what's happening if they do not have enough energy? They simply bounce off each other. So over here, the particles will just bounce off each other. So again, non-effective collision. Non-effective collision. So This place, we said we have a wrong orientation. Wrong orientation. Over here we have, again, wrong orientation. And over here we have not enough energy. Okay, so we are able to establish that for us to form products, we need to have effective collision, and then this collision must involve the particles having the right orientation and sufficient energy. So let's see what happens if we vary concentration and pressure in a reaction vessel or in a system. So on the left side, we have concentration. So think of this as a solution that contains your reactants. So in A, we have only four reactant particles in there compared to the solution. If it is an aqueous, then we'll have water molecules there as the white dots. So if you look at that, we'll say that we do not have enough concentration. So there are going to be collisions, but then we're not going to have frequent collisions. Okay? Frequent collisions because the concentration of the reactant is very small. Now, if you look at B, you have more of the reactants per unit volume of the solution. That means that the chances of collision is going to be high. So there's going to be frequent collision in B compared to A. Now, the more we have frequent collision, and if we say how many collision we have per seconds, then we are talking about frequency of collision. So let me write that. So we have what is known as frequency of collision. So the greater the frequency of collision, the chances of we having effective collision. Is that okay? The greater the frequency, the chances of us having effective collision. And effective collision leads to what? Formation of the product. Is that okay? Leads to formation of the products. Now, in forming these products, the reactants needs to break their bonds. And for them to be able to break that bonds, they need enough energy. And that energy, we call it activation energy. Activation energy, represented by EA, which we have seen when we're talking about the energy changes in reaction, that is enthalpy change. But we'll talk about it again. So on the right, I have pressure. Pressure. One way to increase the speed of reaction or rate of reaction is by increasing pressure. And this one has to do with gases. Okay. So this takes place in gases. When it comes to liquids or solids, we do not consider pressure. But for gases, we look at pressure. Now, when we're looking at state of matter, we said one way to increase pressure is towards reduce volume. Okay, so if you look at A compared to B, you realize that we have the same number of reactant particles in the system, but if we come to B, since the volume is reduced, we'll say that pressure has been increased. And if pressure has been increased, then that means that we are going to have frequency of collision. Okay, high frequency of collision. High frequency of collision will lead towards possibly we having more effective collisions. And effective collision will lead to what? Formation of more products. Is that okay? So that is how pressure and concentration affects the formation of products or rates of reaction. So over here we are going to have rates increasing as concentration is what? Increasing. And over here we have rates increasing as pressure is also increasing. Is that okay? So we've looked at two factors that affect the rates of reaction. We've looked at concentration, we've looked at pressure. We'll continue in the next video.